Hello, everyone. My name is Zach, and this is Science Explosion at Hudson Public Library. Thank you so much for joining me. I'm excited to have you here. All right, so we're doing two different experiments today, and experiments, demonstrations, whatever you want to call them. And to follow along with both of them, you're just going to need a couple things. You're going to need an index card. And I've just got a standard index card here, but you can use one of these ones that's slightly larger if you've got them. Whatever you have that's sort of around the size of a note card will work. And then you're going to need some scissors, and that's for the first one. And the second one, all you're going to need is some balloons. I'd recommend having at least a couple on hand. And some thumbtacks. That's it. All right, so both of our experiments today have to do with principle, and we will get into what this involves, but this is going to be all about surface area. So I've talked a little bit about surface area before, so if you've seen any of the times that I talked about that now, you might want to start thinking about how these have to deal with that. But let's just jump right in, shall we? All right, so we're going to do the step through the index card because that's what I called this one, because I think this is a fantastically cool one. So this is not an illusion. This will actually let you do this. So obviously I look at this thing and I'm like, I'm not going through this, but I'm going to make it happen. So it will involve cutting it. So, but don't worry, it's going to stay in one piece, as long as we end up doing it right. Now I have a couple here just in case I don't do it right the first time, because nobody's perfect. All right, so you're gonna start out by folding it in half lengthwise. So what my teachers always used to call hot dog style, like it's a hot dog bun. All right, so then you're gonna make two cuts. So I'm gonna fold that over a little bit better. So you are going to cut one at each end and start it at the folded edge. So you're going to want to cut this part, not this way, and go in about that much, maybe like a 1/4 inch, whatever that is. And then you're going to cut it, and don't cut all the way to the top. Leave some of it, so like that. And then you're going to do it on the same side, or the other side. Same thing on the other side. That's what I'm saying. There you go. All right, so just like that. All right, so then we are going to be making alternate cuts. So alternating on this, we're going to cut it the other way. And we're going to do about the same thing. Don't go all the way. And then just keep flipping it over and doing that. Give it about the same distance on each of those. And then don't cut all the way to the edge. If you do cut all the way to the edge, you're probably going to need to start over. And just keep going. Oops. Be careful not to let this rip. That's why it helps to use a note card or an index card, because they're usually a little bit thicker paper. Oh, I can cut it a little farther than that on there. I can probably go slightly faster than I have been going, but There we go. So it should look a bit like this. All right, so you should remember not to cut it all the way to the other side. So you should have it look a little bit like a fringy, whichever way you hold it there. So it should almost look like a zigzag on there, the way that you've got it cut. All right, so now we will slide the scissors into the loops that we made on the folded side. But you're not going to cut the first or the last one. So skip this one. And remember, this is the side we folded it down on. Skip this first one and then cut these loops going down all the way to the edge, except for the last one. So skip the first and the last. So you might be able to go a lot faster than me on this, but I'm taking my time just because I don't want to accidentally cut something that you're not supposed to. There we go. So then you're going to unfold it the way that it had been before. It might stick together a little bit, but that's all right. So it's going to look something like this. All right, so now you can start to pull it apart. And there you go. All right, so I think I made my cuts a little bit wider than they should have been and didn't go quite to the edge like I should have. But even with that, you can see this is an index card still. And I think it now makes a lovely necklace for me. Even with my somewhat large head, I was able to easily slip this on there. So if you're a little bit of a smaller person, you could probably fit through the whole thing, but that might be a bit of a challenge for me. Now, if I use this larger one, I think I might have been able to actually get myself step through it. All right, so that's the first one. And remember surface area and start to think about how I was able to get this so that I could do this now. All right, so next up, we are going to pop some balloons and then maybe not pop some balloons. Let's find out. All right, I'm gonna need to move this a bit. There we go. Let's meet down here. All right, so let's get a balloon ready. That looks good. Tie it. I want you to be able to see what I'm doing here. And then let's get a thumbtack ready. Set it right there. And let's set my balloon down. Oh man, I'm not ready for this. What do you think is gonna happen when I set this balloon down, push it just a little bit onto the thumbtack? What do you think? Let's find out. All right. Wow, look at that. It took a little more force than I thought it would, but there we go, popped. So once you press down on it, unsurprisingly, it pops. Now, why did it pop? All right, I want you to really think about that. So you know something sharp can pop a balloon, something like the head of a pin, but why does it pop the balloon? All right, so keep thinking about that. Now, all right, now using video game logic here maybe, you might think, well, one pin does a certain amount of damage to the balloon, but what happens when you add multiple pins? That'll deal more damage to the balloon, right? Well, let's get these set up. I'm gonna have to move these back a little bit. There you go. Now you can see them in my frame. Let's get a lot. However many thumbtacks you've got. Well, maybe not that many. If you have boxes and boxes, don't spend all of your time setting up thumbtacks. And you want to make sure you're spreading them out evenly. Because if you have one that's taller than the others, then you're just having that first one doing the damage and not the others, because then the balloon won't actually reach the other ones. So let's just get a nice field of these. Now remember, be careful. These are sharp and they'll hurt a balloon for sure, but they can also hurt you. So don't get hurt. I know you're all smart people. Just making sure none of these are actually taller than the others. That'd be funny. Like if I had a nail here, it would stand way above all these pins. Let's get a few more. I like to have a nice field here. There we go. That looks like a nice cluster. All right, so this is my departed blue balloon. Let's get a red one. Looking good. And you can see I tried to put about the same amount of air in each of them. I think this makes a stylish necklace. What do you think? All right, so now I've got my balloon. And I've got all of my push pins or thumbtacks, whatever you call them, set out along here, evenly spaced. So what do you think will happen when I push the balloon down onto these? Let's find out. All right, I'm actually pushing rather hard on this balloon. I'm almost pushing hard enough I'd be worried that I would just pop it by the force. Now remember, use your common sense. You might want to grab it by the sides because you don't want to push your hand down into the tacks. I'm pushing very hard on this. And I can feel that the balloon is flexing. All right, so this balloon is not wanting to pop. So by, like I said, video game logic, adding more things that could pierce the balloon, you'd imagine that they deal a lot more damage to the balloon. They would just pop it a lot more quickly, pop it a lot more severely, whatever, but that's not what happened. Oh my gosh, this is not popping. I thought, there we go. Woo! All right, now be careful because these did fly everywhere. So you might want to actually just stop before you get to there. So I would actually recommend putting on safety goggles if you are going to push nearly as hard as I did. That was something that was not great. So these did fly everywhere, so you will want to be very careful with that. All right, so that took a lot of effort to pop that balloon. Eventually I was able to, but I put many, many times more force onto that than I did on the first balloon. So why? Okay, so this necklace I made for myself and these balloons that I popped with the push pins, it all has to do with the same thing, and that is surface area. All right, so this necklace, I have basically turned it from being a 2D object into a 3D object by cutting it, sort of similar to if you watched the round peg in a square hole video. So I'm not going to talk too much about that one, but it is increasing the surface area of it, and it's basically helping it to change dimensions as well. But what about these push pins? All right, so if you look at a push pin, it's sharp. I think everybody can kind of figure that out just by looking at it. And I think you already probably know that sharp things pop balloons. All right, but why do sharp things pop balloons? I think that's a great question. So I'm going to blow up another balloon here. Almost let go of it. That would have been interesting. And I'll tie this one off. Okay, so I'm pushing it down on the table, and I don't feel like this is going to pop, except I almost pushed it onto a push pin. I don't feel like this is going to pop. But why? I'm pushing it onto something just like I would be pushing it on to this pin. But what's the difference? Well, this is sharp. So what does sharp mean? Well, you probably already know. It means it goes into a point. But why does that matter for popping a balloon? Well, you got to think about the force that you're putting on the balloon. So if I'm pushing a balloon down with my hand, no matter what I'm pushing it on, I'm pushing it with the same amount of force. So that just simply is how hard I'm pushing on it. It's got that amount of it. But it makes a big difference what I'm pushing it against. So this table is flat, so it has a huge surface area because it's flat. And so the surface area is just the area of the surface. It's how big the surface of it is. So it's huge. I'm pushing down on this, and I'd have to push this very hard to pop the balloon. It's basically just going to be, the pressure in the balloon is going to be too big and it'll pop. But honestly, I'd have to put my weight into this to pop this balloon pushing it against the table. But against this pin, it doesn't take nearly as much. And that's because even though the force is the same that I'm putting on the balloon, it's concentrated in a tiny surface area. So the surface area of the table isn't the size of the table. It's the size of what part of the balloon touches the table, which I'd say on this balloon is probably about that big going on the balloon. Maybe a little bigger, probably about that, which is a big area. But the surface area of this pin is just that size of the pin head, small enough that it's even hard to see on the camera unless I bring it closer. So if I were to do this, I'm pretty sure it would pop fairly easily. So, and we saw that it did pop fairly easily. That's because this push pin has a tiny surface area. The area of its surface is just that little point. So the force, the amount I'm pushing on it, is the same on the table and on the push pin. So that means that all of the force going behind all of my hand pushing it is concentrated in this teeny tiny little pinprick. And because of that, that is where it's all concentrated on that balloon. So that amount of force is on this balloon wherever the pin is touching it. And that is easily enough to pop this balloon. All right, so think about that surface area. So the smaller the surface area is, then the less force you need to puncture something. So that's why you've got things like knives. So if you have a chef's knife, if it's dull, you're not going to be able to cut things as well for it. That's why you always see chefs sharpening their knives, because the sharper your knife is, that means the finer the point, the smaller surface area it has, and the easier it can cut. And that is why you see swords as a weapon that people have used in all sorts of different cultures. Swords, spears, knives, anything like that, because they bring all the force of a blow down into a tiny little area. So that's why a sword is sharp, because then it can cut through things. That's also why a knife is sharp. So even serrated knives are still going to work on the same thing because they have the teeth that helps them cut, just like a saw would, but they're still going to be sharp. All right, so now it might make a little bit more sense why having a bunch of pins doesn't do more damage to this balloon. It does a lot less because since you put out these multiple pins, then the surface area is actually bigger than it was with one pin. And so the force on the balloon gets spread out to each and every one of those heads of pins. And you saw I put maybe a couple dozen pins there. And so because of that, the force of me pushing on the balloon was spread out to those couple dozen pins. So that is the secret of a famous act. If you've ever seen somebody lay on a bed of nails, you should not be impressed if they say, look at how many nails I'm sleeping on. A bed of 1,000 nails is actually maybe not comfortable, but no challenge at all. I could sit down on that with no problem. But it is a problem if you ever see somebody sitting on a bed of nails with, say, 4 nails. If you ever see, I have seen somebody do that, and that is very impressive. You should never try to do that one unless you have a ton of training in how to do that, because you have the surface area on there. That's also just nails in general. If you notice a nail is long and thin, but it gets even thinner right at the point, that helps it to have a less of a surface area to get driven in there. All right, so this is all about surface area. We had a couple simple demonstrations for you today. You can feel free to try these at home, but remember safety first. I did not know that those pins were going to scatter, so if I were to do this again, I would definitely say it would be a good idea to wear goggles for this, and you're going to want to be safe for it. But I would still recommend doing this. This was a fun one to try out. So this is all about surface area. It's all about understanding why the world works the way it does. All right, so thank you everyone so much for joining me. My name is Zach. This is Hudson Public Library, and this has been Science Explosion. Thank you very much. Bye.